All right, let's try another one, okay? Same instructions, and you're looking for two approximate angles between 0 to 360 degrees, all right? So I know. What do you do first? You got it. Quadrant, baby. Quadrant. What quadrant is sine negative? Well, you know that sine is going up or down. It's up here and negative here, right? Down here. So you know it's going to be either 3 or 4. So you're looking for quadrant 3 and you're looking for quadrant 4 values, okay? So know what kind of angles you have to achieve. So let's punch this into your calculator. That's your second step. So go ahead and take your calculator, turn it on. Inverse sine, oh, let's actually write the equation, guys. Sine inverse, then you'll never forget your steps in what to do. Remember, you have a ratio, you're looking for an angle. So let's go inverse sine. What is it? Negative 0.4793. Let's press enter. Oh, you're so excited because you got some value, right? You're like, oh yeah, I got theta is approximately negative 28.640 degrees. Woohoo! You're so excited and you write this answer down. But you have to realize that doesn't make sense. It wants angles that are between 0 and 360, so positive values, right? So what is this actually? Right? What is this actually? You're right. That, when it's positive, right? When it's positive it, that's actually right here, right? Right? That's actually right here. Which means this guy, it's actually your reference angle when positive. So 28 degrees, 0.648 degrees, it's going to go this direction, but that's your reference angle. So that means you're looking for this angle when you go talk about it wrapping around this way. And you're looking for this angle here, which means you're going from here to here. Those two angles give you the same sine value. So we're going to find that angle. So again, this guy, okay? So don't get too excited when you get your answer. And don't write that down because you're smarter than that. You got to know how to control your calculator. So you know what I'm going to do? I'm going to actually go ahead and multiply this guy by -1. Why? Because I want to make my reference angle positive. So I'm going to write this here. Reference angle, right, is approximately 28.648 degrees. I may need that, okay? I may need that. So which one do you want to find first? I think the easier angle is if I find the one, I'm going to put an approximate sign here. If I find the one in the fourth quadrant. So you guys, I'm going almost to the 2 pi or almost 360, right? Almost around the whole circle, but I stop here, right? I stop here. I go almost around. So how do I get that little part? But I can't say it's negative 28.648. And I can't just say it's 28.648 because that 28.68 is right here. So what do I do here? Think about it. Am I eating a whole pizza? No. I'm actually eating only this much. So you're right. It's going to be 360 degrees minus your reference angle. Okay? So let's do that on our calculator. Let's see what we get. So I go 360, right? 360. Minus, but again, I'm going to scroll back to my original reference angle. I never type in the approximated value, and I say enter, and I get this beautiful value, and it's 331.360 degrees. Does that make sense? Being in the fourth quadrant? It sure does. So that's one angle. Yay! Okay, we found the one in quadrant 4. Now let's go ahead and find the one in quadrant 3. That's a little bit trickier, right? Okay, let's do that. So we're looking for the angle that's in quadrant 3 now, right? So quadrant 3. How much did I go? Oh, I went, what? You're right. For quadrant 3, I'm looking for the one that's here. You guys know how to travel that much. How much did I travel here? You're right, 180 plus the reference angle. So it's going to be basically 180 degrees plus your reference angle. Let's see what we get there, okay? Another thing that you guys can do if you don't want to scroll up is you're going to take this value here. If you want, you can store it. You can store it as, and you can call it however you want. Maybe call it A. And every time you call A, it's going to be your reference angle then, okay? So let's try that again. So it's 180 plus your reference angle. So it's going to be 180 plus, for this case, since I stored the value of the reference angle, which I called A, I could just type in A, and look what happens. I get 208.648. So let's go 208.640 degrees. Let's check that again. So 180 degrees plus, if I scroll back up this, what do I get? 208.648. So I can call it the A, or I can call it by scrolling back up. Yay, and do these angles make sense in quadrant 3? Quadrant 3, angles are between 180, right, and 270, so this makes sense. So here are your two solutions. You see how we're using our reference angles there? All right. Now, I'm going to twist the question a little bit and go here. It says part 4, finding trig values and specify quadrants. And this is number 97 and 99 of your textbook. Let's try number 97 first. It says function sine of theta is negative 3/5. It's in quadrant 4, it's telling you. Wait, is sine negative in quadrant 4? It sure is. They want us to find the cosine value. Okay, they've already narrowed down the quadrant for us. Okay, they want us to talk about the triangle that appears here in the quadrant 4. Let's just draw it so that it looks like this. Opposite hypotenuse. So radius is 5, right? Make it a little bit longer. Make it so it looks like it. You know what? I don't like that, so I'm going to erase it. Okay? 3 is your opposite, so it's shorter, and your radius is 5. Do you see that triangle? And label it 3, 5. If you want, you can go ahead and write a negative sign here, if that bothers you. So now, it's quadrant 4, and it's in its sign. They gave you the sign. So they want us to find the cosine theta. So what do? You're right. This is your reference angle here, right? Okay. Now, you need to find this side. So remember, you have the radius. Remember this equation? R squared equals x squared plus y squared. Well, you have your y. You need your x, right? So isn't it just 5 squared, right? 5 squared minus negative 3 squared, which is going to equal your x squared. That's your fourth, right? So it's going to be x is going to equal 4. All right, so label that so you can see it. Now cosine theta is unmistakable. It's so easy, right? So cosine theta is going to equal, well, look here. Right, 4, hypotenuse is 5, 4/5. Okay, now you try number 99 on your own. Stop the video and try this. All right, let's check our answers. Quadrant 3, tangent is positive. Well, tangent is definitely positive in quadrant 3 because it's going to the left and down. Negative, negative creates a positive value. So we're good. So draw your triangle accordingly here. So it went to the opposite 3. So opposite of the angle is 3. And it went to the left. It went down 3 and left 2. If you want, you can put a negative here. But you don't have to because they're really distances, right? And you're looking for this theta here. So tangent is 3/2, right? Tangent of theta is 3/2, negative 3/2. Negative 3 over negative 2, which is positive 3/2. Now, they want us to find the secant, but you need the radius. So let's do that again. R squared equals x squared plus y squared, right? So let's go r squared is equal to 3 squared plus negative 3 squared, negative 2 squared, which is going to be 9 plus 4. So it's going to be r is equal to root 13. Okay? I skipped a lot of steps here. I hope you don't mind. Now you find your secant. Secant of theta is going to be your cosine theta, which is adjacent over hypotenuse, right? Your hypotenuse is root 13. Let's write that, okay? But it's secant, so I'm going to go hypotenuse first, root 13, over your adjacent, which is negative. But it's negative and negative? No, it's going to be negative and your hypotenuse. Your secant is negative because cosine is negative there, right? Okay? All right, so you guys, I hope that was clear. Good luck.